Here is a question that trips up even experienced software developers. What is the difference between an architecture pattern and a design pattern? A lot of people use those terms as if they mean the same thing. Others know there is a difference, but they cannot explain it clearly. And that confusion matters because using the wrong pattern for the wrong problem is one of the easiest ways to make a software project harder than it needs to be. In this video, we are going to clear that up in a simple, practical way. No jargon, no academic fog, just a clear explanation of what each pattern does, how they are different, and when you should use each one. We will use everyday analogies, a real shopping app example, and a few systems you already know from daily life so the difference actually sticks. By the end, you will not only understand the difference, you will be able to explain it to someone else. Whether you are a student, an IT professional, or just curious about how software is built, this video is for you. Let us get into it. And as we go, keep one simple idea in mind. Architecture patterns describe the shape of the whole system, while design patterns describe the smaller choices that make the inside of that system work well. Before we define either term, let us start with a simple analogy. Imagine you are building an entire city from scratch. Before the first building is even designed, the city planners have to make huge decisions. Where do homes go? Where do factories go? How do the roads connect? Where do water lines, electricity, and communication cables run? Is the city centered around one downtown area or spread across smaller neighborhoods? These are big structural decisions. They shape everything that comes after them. They are hard to change later, and they affect how the whole city works as it grows. That is what architecture patterns are in software. They define the overall shape and organization of the entire system. If the city plan is wrong, every road, utility line, and neighborhood has to work around that mistake. Software behaves the same way. A good architecture gives the whole system room to grow. A bad one creates friction everywhere. Now think about the buildings inside that city. Once the city plan exists, architects have to solve more specific problems. How should the lobby be laid out? Where should the stairs go? How do you design a floor so it feels open, bright, and easy to move through? These are smaller local problems. They do not redesign the whole city. They solve one contained challenge inside it. That is what design patterns are in software. They are reusable solutions to specific problems inside a system. So keep this picture in mind. City plan architecture pattern. Building level solutions design patterns. An architecture pattern is a high-level strategy for organizing the entire structure of a software system. It defines how the major parts of the system are divided, how they communicate, and how the whole thing behaves. Architecture patterns answer broad questions. Should the app be one large system or many smaller ones? Should different layers be separated cleanly? Should the system react to events or process requests in a fixed flow? These are foundational choices. Once a system is built around them, changing them later is a major job. Let us look at 3 common architecture patterns in plain English. First, layered architecture. This is the classic multi-tier approach. The system is split into layers, one layer for the user interface, one for business logic, and one for data. Each layer talks mostly to the layer next to it. Think of a restaurant. The dining area handles customers, the kitchen handles cooking, and storage handles ingredients. Each part has a clear role. Second, microservices. Instead of one giant application, the system is broken into many small services, each responsible for one job. A product service, a payment service, a user service, a notification service. Each one can be built, deployed, and scaled separately. That makes the system more flexible, but also more complex to operate. Third, event-driven architecture. Here, parts of the system do not directly call each other all the time. They publish events, and other parts react to those events when they care about them. A stock trading platform is a good example. When a price changes, multiple systems react at once without waiting on a central chain of calls. The common thread is simple. Architecture patterns describe the shape of the whole system. They are the decisions that affect the whole team, the whole deployment process, and the whole growth path of the product. You are deciding the blueprint before the real building work starts. Design patterns work at a different level. While architecture patterns organize the whole system, design patterns solve recurring problems inside the system, inside a feature, a component, or a piece of code. Design patterns became famous through the Gang of 4 book published in 1994. It cataloged 23 patterns, grouped into creational, structural, and behavioral categories. We do not need all 23 today. 3 examples are enough to make the idea clear. The important thing to notice is that these patterns do not redesign the whole product. They help you solve the same kind of problem again and again inside the code, in a way that is cleaner and easier to understand later. The observer pattern is about notifications. Imagine a news app where you subscribe to sports and technology. When a new story appears, the app notifies you automatically. You do not need to keep checking manually. In software, one object changes state and many others are told about it. You see this pattern in live score updates, stock tickers, and social feeds. One change, many listeners. It is especially useful when you want parts of the system to stay loosely connected. The subject does not need to know what each listener will do. It only needs to say, something changed, and let the observers handle the rest. The singleton pattern is about having one shared instance. Think of one printer in an office building that everybody uses. There is only one, and everyone gets the same one. In software, a settings manager or logging system often works this way, so every part of the app uses the same shared resource. The reason people use it is consistency. If every part of the application reads the same configuration or writes to the same logger, you avoid duplicates, contradictions, and a lot of confusing state. The factory pattern is about creating objects without hard-coding the exact class. Imagine a car dealership. You ask for a 7-seat vehicle with 4-wheel drive, and the dealership gives you the right model. You do not build the car yourself. In software, a factory creates the right object based on what was requested. This becomes very useful when the exact type of object depends on user input, configuration, or business rules. The rest of the code stays simple because it just asks for what it needs and gets back the right thing. So design patterns solve focused, repeatable problems in the code itself. Now let us put the two side by side. The first difference is scope. Architecture patterns work at the level of the entire system. Design patterns work at the level of individual components. The second difference is the question they answer. Architecture patterns ask, how should this whole system be organized? Design patterns ask, what is the best way to solve this specific recurring problem? The third difference is visibility. Architecture patterns affect teams, deployments, scaling, and failure handling. Design patterns usually stay inside the code of one feature or module. The fourth difference is how hard they are to change. Reworking an architecture can take months. Swapping a design pattern inside one component is usually much easier. The fifth difference is the cost of getting it wrong. A bad architecture choice can make a system impossible to scale or maintain. A bad design pattern choice usually causes cleaner or messier code, but on a much smaller scale. That is the core idea. Architecture patterns shape the system. Design patterns shape the parts inside it. Let us make this real with an online shopping app called ShopEasy. The team starts with architecture. They expect growth, multiple teams, and a lot of traffic. So before writing code, they decide to build the app with microservices. They split the product into separate services: catalog, cart, user accounts, payments, orders, and notifications. That is an architecture decision. It determines how the teams work, how the system scales, and how deployment happens. It also changes how people think about the product. One team can own search, another can own checkout, and another can own notifications without stepping on each other all the time. That is the kind of flexibility architecture can create. Now the engineers start building each service, and this is where design patterns come in. The notification service needs to react when orders are placed, payments succeed, or deliveries are dispatched. Instead of writing custom notification logic everywhere, the team uses the observer pattern. Services publish events, and the notification system listens and responds. The configuration module needs one shared source of truth for settings like database URLs, timeouts, and feature flags. That is a job for the singleton pattern. Every part of the system reads from the same instance. That keeps the whole application aligned. If the timeout changes or a feature flag turns on, every part of the system sees the same truth instead of drifting into its own version of reality. The payment service needs to support cards, wallets, and bank transfer options. The factory pattern fits perfectly. The system asks for the payment type, and the factory returns the right handler without the rest of the app needing to know the details. That keeps the checkout flow clean. If the business adds a new payment method later, the team updates the factory instead of rewriting the entire payment flow. So one architecture pattern defines the system, and several design patterns solve the smaller problems inside it. Think about an email service like Gmail. At the architecture level, it is often event-driven. When you send an email, that action creates an event. One service routes the message, another updates your sent folder, another checks for spam. These parts react independently, which keeps the system fast and scalable. That is the architecture pattern at work. Inside the inbox component, a design pattern may also be in play. When a new email arrives, the unread count updates, the inbox list refreshes, and maybe a notification pops up. That is observer behavior again, one change triggering multiple updates automatically. The system feels smooth because the architecture handles the big flow of work, and the design pattern handles the small reactions inside the interface. 2 levels, 2 kinds of patterns, 1 seamless user experience. Understanding the difference also helps us avoid a few common mistakes. The first mistake is trying to solve an architecture problem with design patterns. If a system cannot handle scale, no amount of clever code inside one module will fix the fact that the overall structure is wrong. The second mistake is using architecture patterns too early. A small product for a few thousand users probably does not need microservices. That adds complexity before it adds value. The third mistake is overusing design patterns. Not every problem needs one. Sometimes the cleanest solution is the simplest one. Patterns are tools, not trophies. The goal is clarity. So how do you know which one applies? Ask one simple question. Am I solving a whole system structure problem or a local recurring code problem? If you are deciding how the application is divided, how it scales, how services talk, or how failure is handled, you are in architecture territory. If you are solving how to notify multiple parts of a system, how to create objects cleanly, or how to share a single resource safely, you are in design pattern territory. And remember, they are not rivals. A strong system usually uses both. The architecture creates the structure, and the design patterns fill in the important details. When in doubt, ask what would need to change if the problem grew larger. If the answer affects services, teams, deployment, or data flow, think architecture. If the answer affects one class, one module, or one reusable behavior, think design. Let us bring it all together. Architecture patterns and design patterns are both essential, but they live at different levels. Architecture patterns are the big picture. They define how the whole system is organized, how it scales, and how its major parts communicate. Examples include layered architecture, microservices, and event-driven architecture. Design patterns are focused solutions. They solve repeatable problems inside components or features. Examples include Observer for notifications, Singleton for one shared instance, and Factory for flexible object creation. The analogy holds up all the way through. Architecture patterns are the city plan. Design patterns are the smart decisions inside the buildings. Both matter. Neither replaces the other. Once you understand both levels, you can make better decisions when designing software, reading code, or joining a project that already exists. And that is the real win here. You stop reaching for the wrong tool. You start seeing whether the problem is about the blueprint or the room layout, the whole system, or the small mechanism inside it. Thank you for watching. If this helped, share it with someone learning software development. And if you have not already seen our videos on the Strangler Fig pattern and microservices architecture, those connect directly to what we covered here. Until next time, keep asking the right questions, keep building thoughtfully, and keep growing.